Hi everybody, I hope you did well on your quiz. The next topic we will be talking about is solving proportions, okay? A proportion is an equation that states that two ratios are equal. If two ratios are in proportion, then their cross products are equal, okay? So if we take any fraction, all right, so because the proportion states that two ratios are equal, so we take any fraction, let's say 2/3, and we set that equal to an equivalent fraction or ratio, that forms a proportion. So 2/3, let's think, if I want to make an equivalent fraction, I'll pick a number and I'll multiply the numerator and denominator by that number. Let's say I pick 3, okay? 2 times 3 is 6, 3 times 3 is 9. So those are two equivalent fractions. Now what happens is when we have two equal fractions or ratios, they form a proportion. And not only that, but they're cross products. So a cross product is multiplication. 3 times 6 is 18, and 2 times 9 is 18. So that happens for all proportions. To determine whether a pair of ratios forms a proportions, we check their cross products. So using algebra or variables, if A over B equals C over D, then, and it doesn't matter which diagonal you start with, A times D is equal to B times C. So these directions say determine whether the pair of ratios forms a proportion. There's a couple ways you can do this. You're basically asked, are these two fractions equal? So if you know 5 times 4 is 20, 6 times that same number 4 is 24, yes, you have a proportion because you have two equal fractions. Okay, you could do it that way. You could reduce the unsimplified fraction to its lowest terms. 20 and 24 have a 4 in common. 20 divided by 4 is 5. 24 divided by 4 is 6. Or you can always use the cross product method. 20 times 6 is 120. You can use calculators. 24 times 5 is 120. Because the cross products are equal, we have a proportion. Okay, so 120 is equal to 120. Yes, they form a proportion. Number 2, again, you have those other methods. You can say, well, 2 times 4 is 8, but 3 times 4 is 12, not 15. So these are non-proportional, and you can check the cross products to verify as well. 8 times 3 is 24, 2 times 15 is 30, and because the cross products are not equal, this does not form a proportion. Okay? We've got 18 times 28, which is 504, and then we have 45 times 8, which is 360. And because we have two cross products that are not equal, there is no proportion. Okay, so at this time, I want you to pause the video and try 4, 5, and 6. Okay, please check your answers for 4, 5, and 6. Make sure you got the same answer, so not a proportion for 4, and a proportion is formed in number 5 and number 6. So now we're going to use this idea of cross products to solve proportions. We can use the cross products to help us solve for unknown information in a proportion. After cross multiplying, we will be left with a one-step multiplication equation. To solve a one-step multiplication equation, we need to divide both sides of the equation by the coefficient or the number being multiplied by the variable. So here we're going to solve each problem. We have proportions. One of the spots is missing. So we're going to use the idea of cross products to solve for the unknown. Now, you can read an equation backwards and forwards, but I always like to start with the diagonal, including the variable. 12 times x we write as 12x, okay? And that's going to equal the other cross product. So we're going to have 16 times 3, which is 48. And from here, we made a one-step equation. 12 times x equals 48. So about equations, which we'll get to shortly, like soon in the year, we're going to work on equations a lot. But last year, you solved one-step equations. If x is being multiplied by 12 and our goal is to get x isolated or by itself, we need to do the opposite. So if 12 is being multiplied by x, we need to do the opposite of multiplication and divide. And what we do to one side, we match and do to the other to keep the equation balanced. So x will equal 48 divided by 12, or x equals 4. All right, so then we'll do number 8. Again, I always like to start with the diagonal, including the variable. You don't have to, but that's just my personal preference. So we make our one-step equation based on the cross products. 7k equals 168. We'll divide both sides by 7 to get the variable isolated or by itself, and k equals 24. All right, I like to start in the variable side or diagonal, and I'll get 63a. Another thing to note is that the number always goes in front of the letter. That's called a coefficient. Equals 126, and we'll divide both sides by 63, and we'll get a equals 2. All right, I want you guys to try 10, 11, and 12. Pause the video at this point, give them a try, and then you'll check your answers. All right, check your answers for 10, 11, and 12. It's okay if you have the number on the left and the variable on the right. So for example, in number 10, if you have 31.2 equals W, that's equivalent, totally fine, 100% acceptable. The last thing we're going to talk about today is solving proportion word problems. Proportions can be used to solve word problems in which there is a constant rate. It's very important to stay consistent when setting up your proportion. Which of the following equations is a valid proportion? So remember, the definition of a proportion is two equivalent ratios or fractions. So two completely equal fractions. Well, miles over hours is totally not equivalent to hours over miles. But miles over hours is absolutely equal to or the same or equivalent to miles over hours. That's consistency, and I'll go over what that means when setting up the proportions in number 13 and number 14. Helpful hint, set up a key when writing proportions to make sure the units stay consistent. So number 13 says the ratio of hot dogs to hamburgers sold at a baseball stadium is 8-3. If there were 272 hot dogs sold, how many hamburgers were sold? So when I said the helpful hint was to set up a key, that means to kind of write your consistent units. So the two things we're comparing is the ratio of hot dogs to hamburgers. So that would be my key, just the order that I'm going to set up my proportion. I'm going to have hot dogs in the numerator and hamburgers in the denominator. So I'm getting ready to set up my proportion. The ratio was 8-3. 8 stood for hot dogs, 3 stood for hamburgers. And then I continue reading and I'm given another number in the problem, and that's 272 hot dogs. So here's where the consistency comes in. In my key, it looks like I have hot dogs represented in the numerator. So I'll take my 272 that talks about hot dogs and place in the numerator, and your missing spot will be X. From here, you'll cross multiply. Okay, I like to start in the diagonal, including the variable. 8 times X is 8X. 272 times 3 is 816. And I have to solve my one-step equation by dividing both sides by 8. And I find out that there's 102 hamburgers sold. And make sure when you're writing your final answer, you include the units. All right. Number 14 says the fee to check luggage with the new airline is based on the weight of each bag. Mr. Bell paid $7.14 to check a 42-pound bag. How much will Mrs. Flynn pay if her bag weighs 63 pounds? So it looks like the rate is talking about money and the pound. So money and the weight. Okay. There's my key. That's how I'm going to set up my proportion with consistency. So Mr. Bell is up first, and it looks like he paid $7.14 for a 42-pound bag. The other piece of information I'm given is Mrs. Flynn's 63-pound luggage. So pounds looks like it's represented in the denominator. So that's where 63 goes, and the missing spot is X. X is in the numerator. Numerator represents money. That's exactly what I'm asked to solve for. How much she'll pay. So 42 times X is 42X. 7.14 times 63 is 449.82. and then we'll divide both sides by 42. And we'll get 10.71, so $10.71. Okay, make sure you include that unit in your final answer. Good luck on your homework. I'll see you guys soon.